Hey everyone, Mr. Ray here with our next lesson in logarithms. Today we're going to look at the laws of logarithms. These are properties of logarithms that are going to be very beneficial when it comes to evaluating logs. We're going to be able to break logs down into more simple parts and then evaluate them that way. So we have three laws we're going to cover today, and then we're going to look at a rule called the change of base rule, and this this will be extremely valuable, and we'll talk about that when we get there. For now, let's look at these laws. So these laws, just like we had exponent laws, these will seem very familiar, similar to those laws, and they should, because exponents and logarithms are very related. Okay, so we have something called a product law. You'll notice all three laws have the same name as the exponent laws. So product law of logarithms. So if I'm taking the log of something that's a product of two numbers, x and y in this case, I can actually break those apart and add the individual logs together. So a log of xy is equal to log of x plus log of y to the same base, of course. So that could be helpful. We'll do some examples like that. We have the quotient law, which is division. If you have a number that you could divide into two numbers, if you can rewrite it like this, you could actually write it as the difference. If we subtract subtract the log of the numerator, we subtract the log of the denominator. Okay, so log of x divided by y is equal to log of x minus log of y. Okay, and then we have the power law. So if we're taking the log of something to a power r, we can basically take that exponent, the r, and put it right out front. So I can move it to the front and then just multiply the log of x with the value of r. Okay. Now I'll talk about this when we get there. Right now I want to do some practicing of the laws. So in this case, we're actually taking the result here and we're combining it into a single log. Sometimes we'll reduce it going this way, sometimes we'll expand it going that way. Depends on what works. So in this case, we got the sum of two logs, both of them are the same base. It's very important to check. So this could be rewritten as log base 3 of 6 times 4.5. So 6 times 4.5, that's 27. So log base 3 of 27. And I'm sure a lot of you know this is going to be 3. Just to show you why it is, log base 3 of 3 cubed. So these bases are the same, so the answer is the exponent. Okay, so that's an example of using the product law. So this looks like it's going to be quotient law because there's a subtraction. So I can basically rewrite something like this as a combined quotient. So this would be equal to log, and it's base 2 this time. And again, they have to have the same bases, otherwise you can't do this. Log base 2 of 48 divided by 3, which is 16. Log base 2 of 16. Okay, and again, you could go directly from here to the answer if you know it. If you want to just think about what that means. 2 can be written as 2 to the power 4. So now that I got the matching bases, the answer will be 4. Okay, now this looks like something we didn't cover, but if you remember, we can always write any kind of square root, cube root, any kind of radical, we could rewrite as an exponent, as a power. So the cube root we can rewrite with exponent 1/3. So I'm going to do that very first thing. So log base 5 of 25 to the 1/3. Okay, and remember this is the power law here. So if I see something with an exponent out front, I can just move that exponent out front to the left of the log. So that's going to be equal to 1/3 times the log base 5 of 25. And this time I'll skip the intermediate step. What power do I raise, do I apply to base 5 to give me 25? Well, that would be 2. So log base 5 of 25, that's 2. So it's 1/3 times 2, which is 2/3. Okay, so that's how you use the power. So that makes this look like something we'd have a hard time evaluating, but as soon as we got the 1/3 out of there and it became a multiplier, it was much easier. Okay, so this time we're going to evaluate. So again, using the same laws that we just looked at. Okay, so you can see right away we've got a log that's been raised to a power here. So I can use my power law for logarithms. So I'm going to put that 4 out front of the log. So log base 3 of 9. So what exponent do we apply to base 3 to get 9? Well, that's easy. That's 2. So it's 4 times 2, which is 8. Okay, this one here. So again, this looks like another power law. So I'm going to put the 5 out front. 5 times log base 2 of 8. Okay, and log base 2 of 8. What power do we apply to base 2 to give us 8? Well, that would be 3. So that's 5 times 3, which is 15. Okay, now this is, you can see there's no base there. So it does mean base 10. We have the exponent 2 here. So I'll put that right out front. 2 log, and then my 0.001. Okay, now this one has to require some thought. So 2 log. Now I'll put my 10 here because I want to rewrite that number, that decimal, as a power of 10. So if you think about it, 10 to the power 0 would be 1. 10 to the power negative 1 would be 0.1. And you can keep going. I'd have to go 10 to the negative 3 to get that number. Now that I got the bases matched up, I know that this log is negative 3. So my final answer is negative 6. All right, this one here, similar to one we did on the previous example. This time we have a square root. So I could rewrite the log base 5 of 125 to the power 1/2. So I'm going to take that power, put it out front. Log base 5 of 125. Okay, so what's this? Well, what power would I have to raise the base 5 to get 125? 2 would be 25 and 3 would be 125. So that log is equal to 3. So my final answer is 3/2. Okay. Now, I'm going to do this question here, but this question actually relies on something we were just talking about, but we kind of passed over. So I'm going to go back to the first page. So here's something that's important. If you look at your calculator and you look for log buttons, you'll see a log button with no base, and that's the common log. You'll also see the ln button, the ln button, which should be nearby. So that would be using a base of e. We talked about that in a previous lesson. what do you do if it's something like log base 2 or log base 3 or any other number than 10 or e? Because there's no button on the calculator that does that. Now, I should say there are some calculators that do it, but they're pretty hard to find. So how do you evaluate logs for other bases? Well, this is what you do. So just bear with me and I'll give you an example. So any logarithm can be expressed in terms of common logarithms using the change of base formula. So this change of base formula is going to be your best friend if you want to evaluate any log of any base. So this is saying log base b of m. So b could be any base. M, m's what you're taking the log of. That's equal to the log, so that would be common log m, common log of m, over the common log of b. So that works out nicely because we can do these common logs on your calculator, but we'd first have to, rewrite any other log with a different base as this ratio of logs. Okay, so let's go back and try to do that. So this is, it says evaluate 2 equals 1.05 to the power t. This is the equation to determine how long it will take an investment to double if it earns 5% interest compounded annually. So if you think about it, this is basically multiplying over and over by 1.05. So it's adding 5% over and over and over based on the what you just had. And we want to turn this, if we start with $1, how long would it take to double it? We want to know what's the value of t. So t would be the number of years that it would take to earn double what you started with. Okay, so the equation, I'll just rewrite it here. So this is written in exponential form. If I want to solve this, I'm solving for the exponent. That means I want to find the logarithm. So I'm going to rewrite this as a logarithm. So remember, this is the base, this is the log, and this is the result. So I'm going to rewrite this as the exponent, t, is equal to the logarithm of the base 1.05 and of 2. Okay, so this is kind of weird looking because you have a base that's a decimal. We've never seen that before, but it can happen. So this would be next to impossible to evaluate by hand or even using a calculator. Okay, so what we're going to do, because there's no button that has base 1.05 obviously, we're going to change this into change of base. We're going to do the change of base rule. So this will be a good place to put it again. So log base b of x is equal to log of x over log of b. And that's common log. It could also be, instead of using common log, you could use the ln function. It didn't say it on that page, but you could use either one. I think most people will use that, but you could try this out and see that it works. It actually does work for both. So if I use that rule, this would be the log of 2 over the log of 1.05. So you do that on a calculator, you get rounded 14.2, and that would be in years. And remember, 0.2 years would be, so 0.2 of 12 would be 2.4 months. So our answer would be, therefore, it will take 14 years, 2.4 months. to double the investment. Okay, so that's our first little application question using change of base rule. It's basically solving this equation, and they didn't even put it as a solve this logarithmic equation. It was a solve this exponential equation. But since we're trying to solve for the exponent, we turn it into logarithm form so that the t is isolated. And we can do this, well, we can't do this on a calculator, we can do this on the calculator. Okay, so that's something good to try. And you'll be getting plenty of practice on that. So here's a couple for you here. Evaluate correct to 3 decimal places. So you can see we don't have common log or natural log here, so we do change the base rule. So that's log 17 over log of the base, which is log 5. Do that in a calculator. We get, so we want 3 decimal places, 1.760. Now, how can you test that this works? So there's a good place to show it. So let's check this answer. So this is the exponent, this is the base, this is the result. So I'm going to put 5 to the power 1.760. Now, you can do this on a calculator. You do have a button, y to the power x or x to the power y. You could plug this in, and you should get something that's close to the 17. So, in fact, I think it works out to like 16.99. Okay, and the reason why it's not exact is because we rounded this answer. Okay, the more digits of precision you have, the closer you get to 17. But this is showing that it's practically 17 with just the 3 decimals. Okay, but what you're looking for is you check your work and you get something that's way off. Like if you get something that was like 2, obviously something went wrong here. So this is a good way of checking that your logarithm was evaluated properly. Okay, let's try this one. This time you have a fraction base, so that shouldn't be too much of a surprise now that we saw a decimal base before. And, this should be no problem now because we can do the change of base rule. So that's equal to log of 10 over log of 1/2 or 0.5. And this time we actually get a negative number. Can't remember what the last decimal is. Okay, and again you can check this. You could put the base 1/2 to the power negative 3.32, and you should get something close to 10. Okay, so that's hopefully you can see how to use that change of base rule. Like I said, it's going to be very important to be able to use. Okay, this last question here. We have a fairly complex looking logarithm. We have logarithm base a of the square root of x cubed y squared over w. We want to use the properties we've learned this lesson to break this down into individual logs for log x, log y, and log w. Okay, so it can look a little overwhelming at first. We'll just break it down piece by piece, and you'll see that it's not overly difficult. So this is the original question, log base a of x cubed y squared over w. Okay, so the first thing I see is that square root, so I'm going to rewrite that log base a. I'm going to put the square root as a power of 1/2, and everything under it goes in the brackets here, x cubed y squared over w. So now I can take that, use the power rule, take that 1/2 exponent, bring it out front. So that's 1/2 times log base a x cubed y squared over w. Okay. Now, you can see here I'm multiplying x cubed and y squared, and then I'm dividing by w. So this is really using the product law and the quotient law. So let's see how we can do that in one step. So I'm going to put big brackets around here because I'm actually going to break this apart. But everything I break apart will have to be multiplied by 1/2. So the first thing I see is log base a of x cubed. And then since it's multiplying with this, it's going to be adding log base a of y squared. So I've taken care of the top part. And then I'm dividing by that. So I'm going to subtract log base a of w. Okay, so you can see I've already got it broken down into each of the logs only has one of the letters, but it's still not quite the way we want it. We want to work with these exponents. So 1/2. So that exponent 3 can go out in front of this log base a of x. This exponent can go out in front to log base a of y. This one's okay already. I don't have to do anything special. Okay, now the only thing I have to do now is multiply each of these by 1/2 because they're already broken out into the individual logs that the question asked for. So 1/2 times 3, that would be 3/2. 1/2 times 2 is equal to 1. So just put log base a of y, and then 1/2 times -1, -1/2 log base a of w, and that's our final answer. Okay, so you can really take a scary looking logarithm and you can use those laws to break it apart into very, very simple logarithms. Okay, so that's a good example of doing that. Okay, so I've got some homework questions for you to practice these laws and also the change of base rule. Very important concepts to get used to, so you need to practice those. Okay, so the next lesson, we're actually going to look at some applications of logarithms, and they're very specific applications, so we'll do that next time. Okay, have a good day.